Good day. Today's video is going to be on OSPF operation. So we have a packet tracer here. I'm going to pay attention to the green areas. That would be the LANs off of these routers. So there's 4 LANs. You have this internal, it's a network broadcast multi-access area in the yellow, which means the election process is going to happen mostly here. You have your point-to-point links, which are not colored, just straight lines. So that would be considered your WAN links. So what do we have total networks? 1, 2, 3, 4, 5 in the middle, 6, 7, 8, 9. So static routing would be very difficult. So let's take a look at the operation. Let's start with adding, let's see the advertisements already. So let's go to simulation. Remember, I want to edit out my CDP, DDP, and STP. So if we just let it run, so we see an update coming, another update. So if you just cycle down through them, eventually we're going to find something different. Oh, there's an acknowledgement right here. So I found the acknowledgement. All right, so we went to real time. Then real time back to simulation. So what we want to do now is add a loop back to branch 3. So to do that, config T, INTL back 0, IP address. What did I make it? Now we need to add it to OSPF. So it'd be router, open shortest path first. We're using 10, and then add to network 4.4.4.4. Wildcard is opposite of 255, 0.0.0.0, area 0. Now what I want to do is hit play here and then add this command. And then watch how many LSAs now are going out. Because now we've added a new network and everybody needs to be updated. So these are the LSAs, LSUs, and the acknowledgements going through. So you can on your own start anywhere on the list and keep going through acknowledgement. So these are all being acknowledged that they received the update. So all these are updates, and then we should find there's an acknowledgement with HQ. So OSPF, remember, it creates 3 tables: the routing table, the neighbor table, and then also a topology table. So it can draw a complete, each router has a complete picture of all the networks. So here's your LSAs. We just saw that. We're going to influence the election process either by setting priority, router ID command, or if you don't change anything and they're all equal, it'll go to the highest IP on the physical interface or the highest IP on the loopback. So the election process between branch 3 and HQ to branch 1 and branch 1 to branch 2 and branch 2 to branch 3 are all point to point. So the election is pretty simple. One becomes a DR and the other doesn't do anything. In here is the multi-access where we have 4 local router interfaces advertising. So let's see who currently, by doing show on branch 3, let's see the output here. So I'm going to get out of config. So I'm in branch privilege mode. So on branch 3, your process ID is 10. Here's your router ID .4. It's a broadcast cost of 1. This is the DR. So if you look at the designated router in the IP, it matches this interface. And the designated backup router is .3. And if we look, .3 is on branch 2 gigabit 00. So DR in the backup designated router. And so these would be druthers. These are their branch 1 and HQ right now. So let's set on HQ on interface gigabit 00. So we'll do the priority command, and then we will reset the processes so we can see the election and see if it changes. So enable config T, int gig 0/0. So I did IP OSPF question mark, and then I do priority, and I'll make it 10. So let's clear processes. So clear IP OSPF process. Yes. So once you make a change, we could look at the LSAs and simulation, and you'd see all these advertisements going out. And we detached, and then everybody decided to do the updates. And now if we do the show IP on interface gigabit 0/0, so we're still in HQ. So this is .1, and it is now DR. So we did change the election. Now, if you want to do it further, you can go to a different router and do a different priority, or we could have done the router command with ID. So we did that in the last class. So if we wanted to make, we would go into config T, int gig 0. Oh, router ID, where's that at? Okay, we'll look up where router ID is. It's on the PowerPoint. I didn't have it in here, so I'll have to redo that. And so once you see here, it goes down. So when we look at the open shortest path, it's Ditraska shortest path. It's based on cost, and it's based off the bandwidth. But the problem is when you do the math, fast Ethernet, gigabit, and Ethernet all kind of see the same cost. So let's look on branch 3. We'll do the show OSPF on a fast Ethernet and see what its cost is. And over here is the cost. So fast Ethernet is at 10. And if we change it to gigabit 00, the cost of 1. Let's go over to branch 1 real quick and do the same command on the E0, which is 10 meg. Remember, fast Ethernet is 100, gigabit is 1000, and then Ethernet is only 10 meg. So that's E0, right? Yeah, E. 8/0. And it has a cost of 10. So the Ethernet and fast Ethernet all come up with the same cost. So what we can do is do auto cost. So we go to branch 3 and do interface and an OSPF. So config T, INT at fast Ethernet 8/0. And then we're going to do IP OSPF cost. And then we can put it at, what we want to. Let's put it at 100. Which makes it worse, but we still can change it. And then we would look at the LSAs again, and that would be sending updates on the cost. So let's do a show routes with the pipe and include 12. So let's take a look at where we're going to be in branch 3. And then 12 is all the way over here on branch 1. So we have to traverse this whole network to get there. So get out of config. And let's put the command in. So if you don't remember, O is OSPF, 10 is the network, 10, 10, 10, 12, 0 is the network. 110 is your administrative distance, which is default for OSPF 110. And then your cost is 11 by adding up the cost of 1. So there's a 10 somewhere, which is the Ethernet here. So if we would travel across, this link is 1, this link is 1, and then you'd add 10 for 12. This way would be the same route. So it has to pick which route it would choose over because they're going to be equal cost. And then that's when load balance and load sharing would come into. So let's do .11, 10, 10, 11, 0, which I believe is on HQ over here underneath on the HQ. So change to 12 to 11. And then once again, OSPF is running. There's your network address, administrative distance of 110, and a cost of 2. Because obviously this link would be 1 and then 2. If you went this way, you have with 3, so it definitely would come this way. So your hello and dead intervals are when you send updates. So hello is, or is that route still there? In dead intervals is how long you hold that information. If the route's not available, when do you remove it? So you want it to be default is 10 hello seconds every 10, and then 40 seconds for your dead. So if we want to break OSPF, all we have to do is get into interface gigabit. We want to affect the largest area here, and we'll set the hello and intervals for 5 and 5, which means then you won't have any time to make decisions because it's going to say hello and the dead is going to expire, so it's going to not be good. So let's do hello 5. Then I'm going to arrow up and just remove and put in dead time. So I didn't spell it out, so you kind of see if you put DE and tab, and if you don't want to wait, hit fast forward time and you'll see the message pop up. So I'm going to go ahead and do that. So when I hit fast forward time, see it's full and it's expired. So it detaches, expire, detach, expire, detach. So essentially what we've done is made a logic flaw because we didn't have enough knowledge to know that you should be a 1-to-4 ratio. So this is how OSPF operates, and the most important things we covered today. Next video will be on actually configuring OSPF. I hope this helps.